Hello guys, so we are going to take some important numericals of chemical kinetics. Okay, so let's take some numerical. Yes. So guys, the first question is saying that a reactant has a half-life of 10 minutes. Okay, and I'm saying it's first order reaction. Okay, it is given to you. First order reaction it is. Calculate the K, and second, the what is the fraction of reactant will be left after an hour of the reaction has occurred. Okay, so now as the it is given to you, half reaction is already 10 minutes. So if half reaction is already given to us, so can we write that T half is equal to 10 minutes? Okay, you can convert into seconds also if you want to, or you can also find in minutes. Okay, so it's better to find it in seconds. Okay, so 10 into 60, so it is going to become the 600 seconds. Okay, so this is T half, and if I want to find out the value of K, so K value would be 0.693 divided by T half. Okay, this is the formula for the first order. So 0.693 divided by, and this is the 600, right? So if we write it here 600, so we are going to find out this is 0.63 and this is 6, so 10 ki power minus 2, but we have to take one more zero so that we can do this. So it would be equal to 1.1 into 10 ki power minus 3, right? 1.1 10 ki power minus 3 per second, isn't it? So this is the first part, right? Now if I talk about the second one, what fraction of the reactant must be left after an hour and the reaction has occurred? Okay, so they are asking the fraction. Okay, so guys, you know that for the first order reaction, the basic formula, okay, fraction we have to find out. So we know that the formula is 2.303 log R naught by R. We know that, right? This is the basic formula. R naught means initial concentration, R means final concentration. And how much time is given to you? Time is given to you 1 hour. So as we have already find out in seconds, so better to convert into second. 60 into 60, can I say it become 3600 seconds, right? Okay, so if you want to find out the fraction, so by using this reaction, fraction is automatically will come. Okay, automatically you will get the fraction. So if what is the K here? So don't you think we have already find out the value of K in the first part? 1.1 into 10 to the power minus 3, because it is also the first row and the same reaction it is. So 2.303, what is the time which is given in the question? Of course 3600, which means 1 minute. And the log, what R naught, what is the initial concentration? We don't know the initial concentration, and we don't know the final concentration either. So it means we have to write it directly, R naught by R only, R, not R naught, R. Okay, so everything is going to left hand side. T is given to you 3600, 1 minute in the question. That's why I just wrote 1 minute means, oh, 1 hour. 1 hour means 16 to 60. That's why I wrote 3600. So it means we are going to get log R naught by R. It is equal to 1.1 into 10 ki power minus 3 into 3600 divided by 2.303. So if we do this, so it would be, see, this is if you convert this into 3.3600 into 3.6 into 10 ki power 3. So 10 ki power 3 and 10 ki power 3 cancel out. So 1.1 and 3.6. So don't you think it is approximately equal to 3.6? So 3.6 divided by 2.303. So it would be approximately equal to 3.6, 2.3. So 36 or 23. So it means it would be approximately equal to 1.8 something, right? So it means the log R naught upon R is equal to 1.8, right? So if you want to find out the ratio, yes, 1.7, 1.8 something. Okay, so R naught upon R, so we are going to get the anti-log, right? So we are because when the log is going to that side, it becomes anti-log 1.8. and that value is automatically will be given to you in the question, because without log table you can't find out. So suppose I am giving to you 1.8 anti-log, it is equal to 63.89, suppose. Okay, so if you want to find out the anti-log value, okay, more value you can find out like 1.80 something. So this value is equal to 63.89. Okay, so what is the ratio for that? R naught upon R, 63.89. But actually in the question they were asking the opposite. What? They were asking the fraction of reactant will be left after an hour of the reaction has occurred. What fraction of reactant will be left? Okay, so it means firstly we have to take R naught and then initial. So can you do the reciprocal of that? R upon R naught, what fraction will be left? So you will get the 1 upon 63.89, okay, and 1 upon 63.89, if you divide it, so you will get the approximate 0.016. So it means this is the answer, this is what they were asking, what is the remaining and what is the initial, it is equal to 0.016. Okay, so this is how we have to find out the ratio. Remember that whenever they ask you how much is left to the initial, so you have to find out R upon my R naught. But when they ask you initial upon my how much is left, okay, initial upon final, then answer would be 63.89. So I hope it would be clear to you, everybody. Okay, so guys, the question is given to you. Calculate the rate constant of the reaction at 293 Kelvin. EA activation energy is given to you. Rate constant is given to you. Okay, R is given to you, and the second temperature is given to you 273. Right? I mean, suppose this is the temperature T1 and this is the temperature number T2, 293. Okay, so guys, we know the basic equation for that, which involves the activation energy, right? And there are two. Okay, so we have to find out the rate constant. It means for the second one. So if we want to find out the rate constant at 293, so of course T2 become what? 293, because we have to find out the rate constant at 293. So it means we know the basic equation for that. Log K2 by K1 is equal to EA by 2.303 R. Okay, 2.303 R 1 by T1 minus 1 by T2. Okay, this is the formula which we derive from the Arrhenius equation, right? Remember? Okay, so now guys, log K2 we have to find out. Log K1 is already given to you in the question, 7.87 into 10 to the power minus 7, right? Okay, EA, what is EA? EA is 103 kilojoule. So if it is kilojoule, so we have to always convert into joule. So it become 103 into 1000. Okay, and 2.303 remain the as it is. What is the R? R is 8.314 joule. Okay, and this is 1 by T1. So how much? What is the value of T1? So T1 value is 273 minus T2 value is 293. Okay, so what is the value? So now you have to solve this portion. 103,019. Okay, 2.3 into 8.3, so 2 8 ja 16, but if it is zero point 0.3 and zero point 0.3, so it would approximately equal to 19.14. So 293 minus 273, 20, and 273 and 293. Okay, and this is log K2 7.87 into 10 to the power minus 7. Okay, guys. So firstly, solve the right side portion. Okay. As of now, you can use the calculator also, but in the examination, you have to solve this. Okay. Calculators are not allowed. So if I quickly solve this by calculator, So it means the value will come. Yes, it would be approximate equal to 1.345, right? And this is log K2 by 7.87 into 10 ki power minus 7, right? So when the log come to this side, can I say it becomes anti-log 1.3, 1.345, right? Suppose in the question it is already given to you, okay? Anti-log 1.345, it is given to you 22.13. So can I say this anti-log of this value it is equal to 22.13, right? So guys, what is the value of k then? What is the value of k2? So k2 value would be equal to 22.13 into 7.87 into 10 k power minus 7, right? So this is completely equal to 22 into 7, and so it would be approximate equal to 1.74 into 10 k power minus 5 per second. Okay, I know. Very good. I know certain calculations are there. Okay. So only typical part is calculation. Okay. And rest of the portion is concept. So I hope we can solve such type of question. This was quite easy. Okay. And don't worry about the antilog. Antilog value will be given to you in the examination. Okay. So this was very simple. Yes. So now, guys, the question is given to you. There is a first order reaction, okay, and the rate constant value is given to you, okay. And if we begin with the 0.10 molar concentration of the reactant, how much of reactant will remain after 3 hour? So 3 घंटे बाद कितना reactant मेरा रह जाएगा, right? Okay. So guys, here K is given to you. Firstly, you always have to write what is given to you. So K is given to you 0.0510 per minute. Okay. The time, the T is given to you 2.303 by K. Okay. The basic formula, you know this, log R naught by R, right? Okay. So guys, here the T is given to us 3 hour. So if we convert it into a second, so 3 into 60 into 60, right? 2.303. What is the value of K here? So K value is given to you in the question, right? What is the K value? So K value is given to you, rate constant 0.00510 log R naught. What is the value of R naught? R naught initial. So initial concentration is given to you 0.1, and this is R, right? Because we don't know the final concentration. Okay. So guys, here everything, please take every constant here to the left side. So guys, then what will you get? Um, so you will get, people, this becomes 10800 into 0.0050 divided by 2.303, right? I know there is a, I mean, calculation is quite tough here. So yes, guys, actually here as the it is given to you in the minute, okay, can you just see that the value is given to you in the per minute? So better to convert only into the minute, okay. So 3 into 60 you have to take only, okay. So if it is 3 into 60 you have to take, so rest of the portion will go to this side, okay. And log 0.1, okay, when log go to this side, so it become anti-log, okay. So when you solve this, and here it will remain the 0.1 divided by R, okay. So when you solve this, okay, after that anti-log value is given to you, okay, and then automatically we can find out the value of R, right? So guys, is that clear? Because anti-log value is given to you, so definitely it is going to come 23.9 something, and that value is already given to you, 8.318 into 10 to the power 23, right? So then we can find out the value of R. So this is how we can simply find out the value of like how much portion is left. So guys, I know there is a quite calculative portion, but I guess we can do the calculation quite easily. Okay, this is how we have to do the questions. Yes. So guys, we have hydrogen peroxide, which is H2O2. So it is going to decompose into the H2O and O, right? And this is the first order reaction it is given to you. And K is also given to you 1.06 into 10 to the power minus 3 per minute. Okay. So this is the first order reaction and you have to find out how much time it will take to the 15% of the sample to decompose. So if 50% is going to decompose, so can you tell me how much is going to left? Of course, if 50% is going to decompose, so only 85% is remaining. Am I right? So 85% is remaining as 50% is going to decompose. So we know the basic equation. K is equal to 2.303 by T log A naught by A1. Am I right? We know this basic equation, isn't it? So guys, here T is given to us. The time. Okay, actually we have to find out the time and K is given to you, right? So of course we can arrange this into the opposite order, right? So can we say that T is equal to 2.303 by K. Okay, log. So initial concentration was always the A naught, but now if 25 if 15% is completed, so how much is left? Can I say 85% is left? So 85 divided by 100 is equal to A naught, right? Isn't it? So it will get going to cancel. So guys, when you divide this, so can we divide this into 100 upon 85? So 100 upon 85, if you divide this, can I say it become 20, it becomes 17? So can I say log 17 minus log 20? Right? K is given to you, 2.303 is given to you log, so it become log 20 minus log 17. So these value will be given to you, we can find out, right? Okay, yes. Of course, suppose if I say if 85% sample is going to decompose, so if 85% is going to decompose, so can you tell me how much is left? How much is left? So can I say A naught initial remain the same, but final become the 15 upon 100, and 15 upon 100 means, can we say that 15 means 20? See, 15 upon 100. So can we say 3 and 20? So log 20 minus log 3. So guys, if it is saying that I mean 85% is completed, so can we say that 15% is left? So 15 upon 100 it would be there. So if you cancel this, so it means 3 and 20. So guys, can we say that this will go to upside log 20 minus log 3? Okay. If I ask you for the 85%, isn't it? These value will be given to you and we can easily find out. Yes or no, everybody? So I guess such type of question we can easily do this. Here at the right side मैंने क्या निकाला है, basically 15% complete हो गया है, और इधर की साइड जो मैंने निकाला है वो मैंने निकाला है 85% के लिए. ठीक है, तो बहुत सिंपल है, ऐसे क्वेश्चन हम कर लेंगे. ठीक है, आई होप सबको समझ में आ चुका होगा. बाकी और भी क्वेश्चन करेंगे बाद में. आज के लिए इतना ही रखते हैं. ठीक है, बाकी आप वीडियो भी देख सकते हैं यूट्यूब पे. चलो